Hi, my name is Patrick Franklin. I'm an architect on the Windows 2000 team, responsible for plug-and-play and power management. What I'd like to talk to you today about is how and what we've done to Windows 2000 to make it truly a great experience for a mobile user. So Windows 2000 Professional in a Mobile Environment is the title of this presentation, and really I want to walk you through some of the enhancements, reliability tweaks we've made, and other feature enhancing work items we've done to make the operating system work well and work in the way that we had envisioned from the start of how a mobile user will work with his laptop. So jumping in, we believe that the mobile opportunity moving forward to the end of 2000, 2001, and 2002 is just huge. IDC estimates that in the year 2003, 12.3 million laptops will be sold. Most of these laptops are going into the enterprise or business space, and most of these will therefore be running Windows 2000. So there's a huge opportunity to not only shape the way customers use their laptops and the experience that they get, but also a chance to make it better for them. Let's talk about the top 10 reasons I hate my current laptop. Well, the first one is my screen isn't large enough to list all my hardware profiles. If you remember in NT4, you had the ability to set your configuration statically upon boot. So you had a bunch of hardware profiles, and then you would select which hardware profile you wanted to boot to. It takes longer to install my modem, reboot, create a connection, and dial in than it does just to drive to work in the first place. Again, plug and play improves your life, makes it better. In the past, if you didn't have your modem configured, you had to reboot, come back in, and then do your dial-up connections, and hopefully you weren't prompted at that point to reboot your machine again. I can plug in new devices into my system, but then I can't find the original installation CD to get the drivers. I can't remember the key sequence in order to get into the BIOS to adjust my power settings. And I'll explain a little bit more about this one in just a moment. My favorite one is it takes 2 hours for my battery to go from 100% to 50% and then 30 seconds for the machine to lose all remaining power. My fan makes my refrigerator sound like my fan makes my laptop sound like my refrigerator. I have to reboot so often that I've memorized the BIOS boot up screen. I can never find a big enough crowbar to extract my laptop out of the dock. I close the lid on my portable to have lunch on the airplane, and when I'm done eating, my battery is dead. Then finally, my machine suspends in the middle of a presentation and doesn't come back. So the agenda today is to talk about some of the software advances we've made and some of the hardware advances we've made. Not only us, Microsoft, but we as an industry that we have made to go forward to provide a world-class environment for mobile users. So some of the software advancements that we've made are easier network setup and configuration, making it easier for the customer to get access to their networking, to their offline data, and to their folders, their offline folders for traditional file shares, and I'll explain this. First of all, making it easier for the customer is one of the ways we make it easier for the customer is to provide a unified UI for all network configuration. We have wizards and common property sheet layouts which help the user have a consistent view of the operating system and of the system itself. The Make New Connection wizard guides you through if you're configuring a PPTP connection or a phone line to the phone line or modem, or you're dialing up to the internet, or you want to accept another incoming connection, or whatever you want to do. It's a common property sheet. This is the way you get connectivity, is through this wizard. Now with the common property sheet layout, you have a unified UI for all network config. You have a new connection wizard, and then the layout finally gives you a common UI to configure your Ethernet card, such as in this example, or your modem, which is this example, or your PPTP connection. So this allows you to configure the properties and set the settings for each of the card identically and via the same mechanism, no matter which type of connection you're using. One of the features I like best is networking on the Start menu. This provides easy access to networking and automatically cascades when the new connection is added. So as you can go to the Start menu, go to Settings, and now you'll see that Network and Dialing Up Connections is available as one of the choices. As you click on that, you'll see that you have the local area connection, the VPN connection, and the RAS 800 number that we would use to dial in when we're on the road. So a consistent and easy to access mechanism to get to your networking components. Offline folders is another major enhancement we've made to Windows 2000 to allow users to access network files when offline. The files are cached locally, but appear to the user as though they're available, and it says here that they appear in the actual namespace. And what that means is, although whack server1/public may not be physically available, it appears to the user as though it is. The offline files wizard walks the user through setup in order to configure and choose the settings, such as the automatically being able to synchronize the offline folders when I log on and off my computer. And the offline files folder provides a complete list of the files that are available to you offline. And then finally, one of the things we like best are the balloon tips, which actually lets you know that you're working offline. Now, the synchronization manager is a one-stop for all offline data. It synchronizes offline files and folders, Outlook Express, Internet Explorer, SQL Server, Outlook, and Service Pack 1. And there are a set of open APIs which allow third-party software to participate in offline and online data. I'm going to go ahead and jump to a demo right now and show you how a user might be able to use and configure offline files and folders. Now what I want to show you is how we use offline folders. Here I have a network share to one of the common servers that I use at Microsoft to store my data. I'm going to go ahead and right click on this public where I keep my public documents. I'm going to say make this folder available offline. Now, because I've used offline folders before, I didn't get the pop-up or the wizard, but if you had not used offline folders before, you would have been prompted and driven through wizard. So now that this cached public and all the contents of underneath public as well. Now I can not only cache folders, I can also cache directories, separate directories themselves, separate files themselves, I'm sorry. So I'm going to go ahead and make not only the public directory available offline, I'm also going to make the document ACPI available offline. Now you'll see that the file is available offline by the little glyph that's put in the lower left-hand corner of the icon. So now I've marked these files as being available to me offline. So I'm going to go ahead and remove the net card because I'm going to go home or go on the road. And now you'll see that the files that appear in this directory are the ones that are only the ones that I've made available offline. So then driving down into the public tree, you'll see that I have a text document and an ACPI PowerPoint presentation. So I'm going to go ahead and edit the text document. This is only a test again, and again, and again, if I can spell. Go ahead and save those changes. And now that I've made those changes, I'm working offline. Now I'm going to go ahead and plug back in the net card. So then maybe I'm in a hotel room where I can plug back in a phone card. As I showed you, the configuration in UI is consistent. You hear the familiar beep. Now I'm just going to wait for a second and let the system find the net card, configure the net card. And then I'm going to go ahead and go back into the public folder. I'm going to go to Tools. I'm going to go ahead and Synchronize. Actually, I'm not going to do that. I'm going to go to this folder's offline. I'm going to click on that. and then I'm going to hit synchronize there. Now it's going to synchronize those folders. It says synchronization is complete. I'm going to go ahead and refresh this screen. And it didn't work. There we go. It's because I was down in the wrong directory. So now you'll see that my file folder is refreshed. So that basically gives me the ability to work offline. Going into public, you'll see that the changes I made are now synchronized up at the server. Other features which are provided to you via Synchronization Manager are going to Programs, Accessories. If I go to the Synchronize Manager here, you'll see that I can have my choice about what items I want to synchronize. So synchronize my current home page. I can say, well, I really don't want to synchronize my home page. I can also, via the setup window, choose via my connection. Here you see I don't have a LAN connection, but if I have a modem connection and other connections, I can selectively choose what files I synchronize. If I'm connected via network card or I'm connected via modem. If I'm connected via modem, I may not want to synchronize as much over a 28.8 or 56K modem as I do when I'm on my LAN connection. And then there's simply choices that say automatically synchronize when I log on, when I log off, ask me before you do it, etc. Now that we've covered some software advances, let's look at some of the hardware advances that we've made to make the platform reliable, robust, and truly a premier environment for the mobile user. We're going to talk about some of the issues with the hardware today. Talk about ACPI. We'll define what that is. Talk about APM versus this thing called ACPI, and then talk about plug and play. So what are some of the issues facing users today? Well, first of all, the issues are the PC or the laptop is too slow to start. That the PC must be on in order to respond to events. The PC is too noisy, uses too much power. Again, remember with the top 10 list, my fan on my PC makes my laptop sound like my refrigerator. You have inconsistent system behavior. The wake-up methods, for example, the modem ring, is not generic or extensible. The power states, standby versus suspend, is not interpreted uniformly throughout the industry. The hardware, the BIOS, the operating system, and the applications do not cooperate to effectively manage power. Not only right now do they not cooperate, they actually work against one another to a degree to manage power on the system, where you have a BIOS that may be working against an application to manage power on the system. What ACPI enables. First of all, ACPI stands for Advanced Configuration, which is the plug and play half, and Power Interface, which is the power management half. What ACPI enables is both power management and plug and play in Windows 2000. It integrates system board devices into driver-based power management, device power management. It improves plug and play support. How does it improve plug and play support? It gives a better description of the hardware. It provides more flexible device ejection and resource configuration. It does a better job describing what is happening in the system so that the operating system can work together with the hardware, with the BIOS, in order to create a robust environment. It improves robustness. Power management policy is coded once in the operating system and not in every BIOS. So as I mentioned before in the top 10 list, whereas you had with each laptop, depending on what type or model of laptop you had, the way in which you configured your power management settings was different. And it was different because you had to go into the BIOS in order to configure those settings. Now, the power management policy is coded into the operating system. So now you have a unified and consistent UI to manage power, whether you be on an HP OmniBook 4150 like the one I'm using here, or a Tegra Toshiba Tecra 8000 or an IBM ThinkPad 600, you manage power the same on all those machines. One of the other features of ACPI, as far as robustness goes, is the control code is executed within the operating system environment. This is a subtle point, but adds to robustness. In your old days, when you removed a laptop from a docking station, you went and executed code that the operating system could not visibly get access to, couldn't debug it, couldn't manage it, couldn't do anything if it were to break. With ACPI, that control is tightly coupled with the operating system, to where a machine, when you go to undock it, won't freeze on you. You may not be able to undock it, but it won't go away on you and force a reboot. Finally, ACPI eases development. You have standard components, drivers and chipsets. You have abstract and flexible. The hardware can evolve without software changes and vice versa. Some of the supported ACPI features are plug-and-play and power management. Some of the features of power management include standby, to where the machine goes to a suspend to RAM state, hibernate, in which the machine suspends to disk, where all power can be removed, hot and warm docking and undocking, dynamic device insertion and removal, and some of the wake-up events, which include a real-time clock, so I can wake up on July 15th, 1999 at 4 in the morning, or February 1st, the year 2000 at 3 in the morning, or whenever I want to set that wake-up timer. Wake-up events on PCI, USB, PS2, and serial connections. Some of the things that aren't supported with power management are card bus wake-up is not supported, which includes VCON LAN for card bus. Now we hope to get this feature into 5.1, but for Windows 2000, the initial release of Windows 2000, card bus wake-up will not be supported. PCMCI wake-up will not be supported at any point in time. The goal is to get the new technology, as we get new technology moving forward, to be able to wake up the machine using consistent and reliable signaling and messages, so that the machine doesn't wake up at 3 in the morning and try to figure out why it's awake. Now, just to further emphasize this point, the difference between card bus is a PCI-based credit card network card. So I'm going to go ahead and pull out my card here and show it to you. So whereas this is you see my pop-up for the whereas you see that you have a credit card style, this is a PCMCI card. Card bus looks exactly like it, but is based on PCI and not ISA. So you just got a plug and play demo in the middle of my presentation. And it beeped in. What machine should I buy? The Windows 2000 ACPI Good BIOS list has generated a lot of interest, but is also a valuable tool for you to use to determine what machine you should buy. If a machine is found on the ACPI Good BIOS list, then ACPI is turned on by default. Machines that are on this ACPI Good BIOS list are guaranteed to have a base level of functionality for Beta 3 and RTM without the requirement of a new BIOS. So what I tell people now is, as you go to prepare your machine to make sure your machines are year 2000 compliant, also test those BIOSes against Windows 2000 Beta 3. In that instance, then your machine will be ready not only for the Y2K, but they'll also be ready for Windows 2000 when it becomes available. A BIOS upgrade may be required for enhanced functionality, such as hot docking. So you may have full functionality, but a particular feature won't work. You may be required to get a new BIOS at that point in time. It should also be noted that all BIOSes with a BIOS date of 1199 or newer will be considered good. To boil all this down, and what machine should you buy, is you should buy a machine that has the Windows 2000 logo. It's Windows 2000 ready. I'll also point to a site where you can get your new BIOS. If you need a new BIOS, a place you can go to is www.hardwareupdate.com. This website is an industry site which will provide links to the OEM sites to where you can find your BIOS quickly and easily. I want to talk about APM versus ACPI. Talk about the old way we used to do it versus the new way we're doing it. APM stands for Advanced Power Management. With APM, the BIOS manages power management. BIOS decisions are not well communicated to the operating system, if at all. The power states are poorly defined, such as standby versus suspend. Standby on some machines is lower power state than suspend, whereas on other machines, suspend is a lower power state than standby. The event handling interface is poorly defined. Again, the machine will wake up off of a modem ring, but the reason the machine is alive and the reason the machine woke up is not very well communicated to the operating system. So the operating system, for example, when the phone rings, the machine wakes up, and the first indication that the operating system gets that the machine is waking up is that it gets the incoming telephone ring. So there's really no notification that we woke up because of the telephone. It's more of an issue of I woke up and therefore I'm going to answer the phone. Finally, you get hundreds of BIOS versions. Each machine has its own BIOS version. Again, you get the inconsistency between the reliability of the BIOSes and the robustness of the BIOSes, and then you get the differences in the configuration, and then you just simply get a non-consistent and reliable environment. With ACPI, the OS manages power management, communicates changes to apps and hardware. The power states are strictly defined. The event handling interface is strictly defined, to where when a modem wakes up the machine, it provides a ironclad, absolute mechanism via notification to tell us why the machine woke up. And then the chipset-based, fewer than 10 chipset designs, the chipset design is a register-based interface which provides consistency. Bottom line is ACPI is more controlled and has fewer opportunities for problems and bugs. Talk about some of the supported plug-and-play features. On all machines you have full plug-and-play. Dynamic enumeration, configuration, arrival and removal, support on PCI, AGP, PC card, USB, 1394, and ISA plug-and-play. You have limited support on ISA and ESA. Limited support is static configuration. So if you add a raw ISA device to your system, then you can statically configure those devices. We rebalance resources across bridges, such as AGP. Enhanced plug-and-play event notification over Windows 98. Applications in both an ACPI environment and a non-ACPI environment can participate in plug-and-play events. This enhanced plug-and-play event notification allows those applications to participate. Again, remember, it's the entire system working together to manage plug-and-play and power management events. Security checks on all plug-and-play events. Support for Windows Update in driver installation, and signatures of drivers are checked during install. Now that's on all machines. For ACPI systems, you have device locking. For instance, you may be familiar with a JAS drive, where you can't eject a JAS drive out of its player unless the device is not busy. So you can lock devices into the system with ACPI. You have enhanced interrupt routing via the PCI routing tables. That's more internal GUI, but it's critically important in order to get a consistent and reliable resource distribution and allocation. Now ACPI, here's one of the big features that ACPI provides. ACPI provides hot and warm docking. So if you want to dock and undock your machine, you have to have an ACPI machine. If you want to dock and undock your machine, you've got to make sure that your BIOS is updated. There are some requirements for docking in that you cannot dock and undock if you have any ISA devices in your docking station. So if you have this laptop, which is a 4150, and if we could get a picture of this laptop, we get the 4150. If I have a docking station that I slide this system into, if that docking station has, for example, an old ISA sound card in it, then that sound card, the dock will continue and work fine, but that sound card won't be detected or found out about. For legacy systems, a legacy system again is a non-ACPI machine. For docking, you have cold docking only, no warm or hot docking. For legacy machines, the motherboard device configurations are treated statically, and the interrupt routing is done through a BIOS construct, which was through the plug-and-play BIOS of $PIR, which is a less deterministic method for interrupt routing. What is not supported for plug-and-play on Windows 2000 is non-multi-mon video adapters in the dock. So if you have a video adapter in your dock that is not a multi-mon video adapter, then that adapter will not work when you dock. You'd have to reboot if you wanted to change your primary VGA display adapter. Dynamic plug-and-play events and configuration via plug-and-play BIOS. What this somewhat complicated sentence says is that for non-ACPI machines that rely on plug-and-play BIOS, hot docking and warm docking will not function. Hot plug PCI and hot swap PCI are features going forward that will not be included in Windows 2000. Multi-level rebalance, again this looks a lot like plug and play where you're doing rebalance not only across a single bridge but across bridges that have child bridges underneath those. That is not supported in Windows 2000, will be in the future. Then some PC cards that aren't supported, SRAM cards, flash memory cards, will not be supported. Additional mobile technologies that are supported, USB, PC card. PC card encompasses both card bus and PCMCI, device bay, infrared, 1394, FireWire. Driver cab. Driver cab is the mechanism by which when you put in a new card into your system, the operating system doesn't prompt you for the CD because we have a cab file very much like Windows 98 in which the drivers are all bundled and placed on your system. So you can't get in a hotel room in Cincinnati and not have access to your CD. The mobile environment in Windows 2000 is better because it's best of breed class drivers, consistent vendor neutral implementations, and it's simply more reliable. Now what I want to do is I want to go ahead and give you some of the demos, give you a couple of demos on how plug and play and power management works on Windows 2000 and show you some of the features and some of the things that we've done to make it easier for you to use Windows 2000 in a mobile environment. The first thing you may have noticed when I just came up to the machine and surprise removed the device, and what surprise remove is I just walk up to the machine, don't tell the operating system that I'm going to remove a card, and just remove it from the system, I get an unsafe removal of the device. I'm going to click OK, go and add the device back into the system. Now, what I can do to avoid those messages and to improve robustness, not only in the operating system, but for applications, is I can provide advanced notification to the operating system that we want to remove this device. So down in the lower right-hand corner in the sys tray, you have an unplug or eject hardware applet. I'm going to go ahead and click on that, and you'll see that it gives me the choice to either stop my CD-ROM that's in the device, DVD-ROM, or stop the Zircom Ethernet adapter. So I'm going to go ahead and stop the Zircom Ethernet adapter, and you'll see that now I get a pop-up that says the Zircom credit card Ethernet adapter can now safely be removed from the system. Now I can pop the device out, and now I won't get the message. What this allows for, it provides notification to applications that the user wants to remove the card, and it provides notification to the operating system to stop all traffic to the card. So you get an orderly removal. The same concept applies with docking. You tell the system that you want to undock it from the docking station so that the operating system and the applications aren't surprised as a result of a device dynamically disappearing. Plugging the network card back in and looking at some of the power management features, you'll see that I have a shortcut to the power options on my desktop, which is basically from the control panel. And here you'll see that I have a number of power schemes. Going up to the power schemes, I'm sorry for the extra goo on the screen, but that's power schemes in Indic language character set. I'm going to go ahead and go to always on. And you'll see that's always on. My machine doesn't stand by ever, but I'm going to go ahead and select after 5 minutes to stand by when I'm plugged in, and after 20 minutes to go ahead and go to hibernate. So what these settings will do is after 5 minutes the machine will suspend if it hasn't been used when it's on AC power. 15 minutes later, or after 20 minutes, the machine will wake up and then go to a lower sleeping state. Whereas I mentioned that standby was to suspend a RAM, hibernate and consume some power. Hibernate is a suspended disk and consumes no power. It is a very effective and efficient means by which to manage power management on the system. Now, those are pretty aggressive settings for AC power. Again, I can have different settings between DC and AC power. So here I'm going to go after 10 minutes on AC. On DC, I'm going to stand by, and maybe after 45 minutes and choose some more reasonable values. On AC, I'm going to suspend after 45 minutes and hibernate after 3 hours. And on batteries, I'm going to suspend after 10 minutes and hibernate after 30 minutes of inactivity. You have the alarms in which when your machine starts running low on batteries, I can basically cause an action to happen. So when the alarm goes off, this particular computer will now hibernate. Go ahead and hit OK. So now as my battery gets critical, I can save the contents of memory to disk and then pick up where I left off once I find an additional power source. Got the power meter, which provides battery information for multiple batteries. The Advanced tab. The Advanced tab allows you to configure your lid, your power, and your sleep buttons, along with being able to prompt for a password when the computer goes off a standby and showing the icon on the taskbar. One of the ways you can quickly determine if you're running on an ACPI machine is to determine if you can configure your power buttons. If you can configure your power buttons, then very likely you're running on an ACPI machine. If you can't configure your power buttons, you're absolutely not running on an ACPI machine. That's one of the fundamental benefits of ACPI, is it allows us to configure those power buttons as well as devices. Hibernate, as I've mentioned a number of times, allows you to suspend to disk. Hibernate is not enabled by default on the operating system because of the disk space requirement needs to be reserved. Now in this case I have 192 megabytes of memory on my system. What I need to do when I enable the Hibernate file is you'll see that my available disk space then decreases inversely proportional to the amount of memory I have in the system. So now I have 192 megabytes less free disk space as a result of enabling Hibernate. So given all that, now I can go to my Start menu with my features to end this demo and do Log Off Patrick Franklin, Shut Down, Restart, Standby, or Hibernate, and simply a menu item for the user. So that basically provides some of the plug-and-play and power management features, as well as the offline folders that I demoed to you earlier. And I think that you'll find that Windows 2000 is a premier mobile platform.